I'd like to share the story of how my father, John Cooper, played a vital role in bringing the first commercial multi-channel cochlear implant to life. In my career as an audiologist, I had the privilege of witnessing countless lives transformed by this incredible Australian invention. From children being able to develop speech and communicate with their hearing peers, to adults who'd had their hearing taken by sudden hearing loss, have their hearing restored. There's no doubt that the cochlear implant has been revolutionary in the treatment of hearing loss. But what many people may not know is just how challenging it was to bring this technology from its initial research and development stage to a product that could be manufactured commercially to serve the hearing needs of people around the world. I've had a unique glimpse into those early days through listening to my dad talk about his experiences over the years. So recently, I sat down with him to capture this piece of untold history from his perspective. Dad shares how he helped overcome some major challenges in the early days on two of the vital parts to the cochlear implant: a titanium case and a ceramic disc that held the 22 electrodes. It's quite possible, had they not overcome these challenges, that the cochlear implant may not have become the groundbreaking technology it is today, transforming the lives of millions of people around the world. These pivotal innovations laid the foundation for the cochlear implant's success, and I'm incredibly proud of my dad for the role that he played.
I was working for Telectronics and they made pacemakers, and I was doing the R&D on pacemakers and other medical devices involved with heart. And Cochlear started up in one corner of our building with an engineer and a couple of other people.
And when would this have been?
Late 79, early 1980. One day this engineer came around and he was trying to pick my brains, and I said, what? He looked like he was worried about something, and I said, what's the problem? And he said, we're having trouble getting parts made, because they had been given the task of miniaturising the cochlear concept from Graham Clark. And so I said to him, can you give me some drawings so I could see what's the problem? So he gave me some hand sketches and of some components they had drawn up. And I stayed, because I managed this area, I stayed back one weekend and worked nearly all weekend, and I made one set of these components that he was having difficulty with. And on Monday, when he came around, I showed him these parts and said, is this what the problem is? And the jaws sort of hit the floor, and everyone was, oh dear, they were sort of all out beside themselves. How could you make some more? So I made some more. And then another vital component was that this engineer was trying to make a ceramic which was going to be a feed through with the 22 channels, or some terminations for the 22 channels, and it was a ceramic component with platinum pins in it. Anyway, he was asking me if I had anything heavy, and he was trying to get a mud form of ceramic squeezed between two bits of glass, and with heavier objects. I could see this was not going to work. Anyway, every time he peeled one piece of glass off, the thing curled up on him, and he was asking how he could keep it flat. And anyway, the long story short, I actually got a pre-fired, because Telectronics made their own ceramic components to do with pacemakers, feed-throughs and connections, and so I got the guys in the other factory that did those to extrude me a 25mm diameter length, about 300mm long, of ceramic, but I wanted it not in mud form, I wanted it pre-fired, which made it workable. So with the aid of some of the machinery I had in my area, I ground this with a grinding attachment to a diameter. Now ceramic shrinks 17%, so this had to be 17% bigger than the finished diameter. So I made this, I ground it to this size, bored the centre hole, And then I had a disc, cutting off disc made. It was just a disc about 1/2 millimetre thick, but I had it sent away to somewhere and got it coated with a cubic boron diamond-like compound, because ceramic's very abrasive. So I was able to cut these discs off at the 17% larger than the final thickness. So anyway, this worked, and then I made a jig to drill the holes for the. I got the drawing for the plotting of the 22 holes, and so I made this jig and put each one in a jig and drilled it, and they got them fired and it worked. But because they needed to have some means of attaching a wire, they put a 1 millimetre diameter platinum pin in each one, and once the ceramics shrunk 17% in the firing process, it sealed, it shrunk around these platinum parts and actually formed a hermetic seal. And then they bought a machine that they used to lap the surfaces, the one surface. So because there were going to be two of these, one in the bottom part that held all the electronics, and one in the cap that screwed on with the top part, and then that had the electrode that went into the cochlea. So these had to be lapped to a perfect flat finish, which they did. The can that I made, I said to them originally that should be pressed, and they said, well, we don't know what thickness of titanium we need to get, and we have to get, I think that it sticks with me, it was $40,000 worth to get a batch of this thickness made, and if that didn't work, another 40,000. And in the initial stages they weren't sure enough to spend the 40,000, so I turned these cans, which were about 20 millimetre diameter with a 0.2 wall thickness and about 8 millimetres thick high. They were 0.2 wall thickness of
a millimetre.
Of a millimetre. So
wow.
I turned these out of a solid 1 inch diameter bar of titanium, and they turned out very well, but the ceramic had to be fitted to that. So then there was a little cap that I made that was extruded. I made a little extrusion die and extruded the whole. It was like a U shape, circular but U shape in section. And once it was extruded to the same diameter as the outside diameter of the ceramic. And they got this brazed in with a hermetic seal once again, and then that just fitted nicely into the cap or the can that I'd made out of the titanium. But then the next problem was they needed to weld it. So another guy and myself, who did electronics for pacemakers and I did mechanical, between us we made a vacuum welder, TIG welder. And this welder, when they pressed it, had all the electronics in, everything was connected. We put this little thing in the welder, and it just ran a weld all around it, sealed it perfectly. The next thing they had a wire coil in there that came out of 2 feed-throughs in the titanium piece that was connected from the inside to the outside. This big coil was going to be read by another device. Once it was implanted, this was going to be read by this other device. But they said, you can't just implant this, it's got to be in some sort of silicon housing. So I ended up making a mould out of brass, and I moulded these for quite a long time.
Wow, I didn't realise that.
Yeah, I made it.
I mean, I always think of it as you played a really pivotal role in bringing the first commercial cochlear implant to life.
I believe so, because they had been trying in different countries to get this can made, the titanium part, and I think most people, initially I think they were trying to get it made of ceramic, and that didn't work, and then they drew another one up out of titanium, but then they couldn't get. Most people I think that said, well, you've got to have dies, you've got to have a sheet, you've got to press these out, but they didn't have the titanium, and it was my idea to make them out of solid. No one had thought of that until I turned them out of a solid bar.
It's quite incredible. I find that they can have an idea, and I'm sure people come across problems like this all the time in manufacturing, but you can have a concept and a drawing and an idea for something, but until you can actually, you know, have the tools and the processes to make it,
Yeah.
it's, you know, it's just an idea, right?
They probably die. A lot of. There's a possibility a lot of inventions don't go any further because they come up against a snag where they can't get something made. And I mean, I had a reasonable mechanical background, having worked in titanium and platinum and silicon, all these components for my pacemaking R&D. So I had a bit of a head start.
And how long had you been a toolmaker at the time?
Oh, finished the trade probably back about 1969. So I'd worked in mechanical and done various other courses and worked in that from 1969 at different couple of companies, and then eventually went to work at Telectronics in 1977. So I was working on pacemakers from 1977 till in the early 80s.
So you did some pretty impressive medical grade
Yeah, I did.
stuff.
I mean, there was even components I made. Once they had the implant sorted out, then they had the wearable speech processor, which wore on your belt, and they had that connected to some sort of telemetry item that read the coil that was inside the brain, inside the head. So I made parts for that. So I did pay a pretty reasonable part to it.
So you were working for Telectronics
Yeah.
at this time, and you were also doing all this stuff for Cochlear. How did
I was
that work
doing
for
this
you?
after hours. And when they used to come round during the day and ask me questions, I'd say, look, go away, come back at 4:30 when I finish working for Telectronics. And then I said I can't keep on doing this, but then I eventually bought a good machine, and I started working from home doing this, so I didn't have to go back into the factory at night after the kids were in bed.
Cochlear had a part to play in your establishing your own business and
Yes,
working
they
from
did.
home, didn't it?
I said to at one stage I couldn't continue making all these parts after hours using company equipment. So I said, if you buy me a lathe, I'll continue making the stuff. And they said, we can't do that.
Because how much would a lathe have cost back then?
22,000.
And that would have been a
1980.
lot of money back then.
Well, it was more than I borrowed for our first house. About 5,000 more. Anyway, so this all went in front of Paul Traynor, who was the director of the group of companies that Telectronics was part of, and Cochlear. And so the purchasing officer, the next day later or something, came in with a purchase order for $22,000 worth of parts. So they said, you can go and buy a lathe, which I did. So, but I continued making them after hours, parts. And by the time I got my lathe, I could then start making them from home. So I continued working for them, doing various components. And there was a component I still made up until about 2022. So I worked for them for over 40 years.
It's a long time. And you didn't just make components for the implant itself, did you? You actually made some of the surgical components too.
Yeah, I did some work on the surgical tools. There was one that was like a ring, and they put that against you. They drew a circle, and then they took a skin flap off, and then cut a hole in the I think it's the mastoid bone behind the ear. And then there was another one that they had to grind a hole, make this hole in the bone. And there was another tool that was just a round disc on a handle, and once that fitted into the hole that they ground in the bone, they knew the implant would fit, so they popped it in there and connected. They had another tool I made a few of. It was like a long, very, very thin tool. It was very long and thin. That went inside the cochlear, and they had a little U-shaped claw on the end of it that I machined out of. Oh, it's all solid steel, a special grade of stainless steel, and they used that to poke the implant, the electrodes in through the cochlea. So I made those for years.
And some of your parts were even displayed in the Powerhouse Museum.
These insertion, an insertion tool and a drilling guide. They were in the old Powerhouse Museum. So yeah, all this stuff sort of goes back a long while. So I had a more than 40-year career with Cochlear as a contractor.
And was this one of the most challenging engineering problems you've had to face?
Yeah, I think so. Yeah, undoubtedly it is. So I enjoyed doing it.
Well, you're a part of history now.